Hey everyone! So, in this video we're going to be starting a new branch of differential calculus. I know there are a lot of them, but this one's a bit of an interesting one, known as related rates. So this is actually one of the concepts that I struggled with initially when I was doing it, but actually when I found out how to do it, I found these to be one of the easier problems of the whole differential calculus section. So, without further ado, let's get right into it. So let's look at this problem here. A balloon which always remains spherical has a variable radius. If the radius is increasing at the rate of 3 units per second, then find the rate at which its volume is increasing with respect to time when its radius is 12 units. Okay, first thing we have to identify is what we've been given and write that out. So it's telling us that the radius is increasing at a rate of 3 units per second. So we can tell that dr over dt is equal to 3. And I know this part over here may seem really confusing at first, but I'll explain right now. Basically, a rate of reaction, like a rate at which something is occurring, is always written as d something over dt. And in this case, I've given r to be the thing here because the radius and radius starts with r. So it's just easier for me to use it later on. But when we're looking at rates of change, or the rate at which something is changing, it is always dt at the bottom. That's very helpful to know. So we've given that dr over dt is 3, which obviously is a differential value because we're looking at the instantaneous rate of change, so obviously it's written in this format. But we are also given that we're meant to find the rate at which its volume is increasing with respect to time. So it's given us that it's respect to time, and we know that respect to time means it's over dt. But it's asking for the rate at which its volume is increasing, so we can say that they want us to find dv over dt. But that's all we've been given, apart from the fact that we need to do it at 12 units, which isn't relevant right now. First thing we do with any related rates question, which typically brings along 3 variables, is construct an equation and gets what we need. So we need to find dv over dt. Well, with the information we have, we can construct a multiplication equation. So dv over dt is equal to dr over dt times something. And we need to find that something. That's the main point of the question. Well, we just need to know that what do you multiply dr by dt with to get dv over dt? Good example of this, well, not example, but a good way to do this is to divide dv over dt by dr over dt. So that's dv over dt divided by dr over dt, which is equal to dv over dt times dt over dr, as we're just flipping the fraction. And these two cancel out, so we get dv over dr. So our question mark, or well, not our question mark, but this blank space over here will be replaced with dv over dr. What we can do right off the bat is substitute dr over dt with 3, because that's what we've been given. So now we have dv over dt equals 3 times dv over dr. All that's left is for us to find the value of dv over dr. And that's the main point of how we tackle these questions. So dv over dr, let's look at what we're given. So the balloon is always remaining spherical. So we need to just find the equation for a sphere. So the volume of a sphere, because we're trying to find the volume in this case, just note that we're trying to find a relationship between the volume and the radius as shown by dv over dr, because v is the volume, t is time, and r is radius. So we can say that the volume is equal to, and then the volume of a sphere is given by the equation 4 over 3 pi r cubed. That's why the spherical part's really relevant. And if we differentiate this equation to get dv over dr, which is precisely what we need, we get dv over dr is equal to, and then 3 goes down here, which cancels out this 3, so it's 4 pi r, and then the 3 goes down by 1, so that's 4 pi r squared. So we've got dv over dr, but it has an r in it, and that's where the radius being at 12 units this part over here becomes relevant. We just substitute r as 12. So dv over dr at 12 units is 4 pi 12 squared, which is equal to 144 times 4. What's 144 times 4? Let me just get my calculator to work that out. Okay, 144 times 4, because 12 squared is 144. That's 576, so it's 576 pi. Now, we just multiply 576 pi by 3 to get dv over dt, which is equal to 1728 pi. With this as our answer, all we need to do is find the units. So our answer is 1728 pi, and now we need to look at what we're like the actual measurement that we're trying to take, and therefore come up with the appropriate units for it. So it's asking for the rate. Our rate is always per second, just like over here. But it's also looking at the volume, and a volume is a cubic measurement, so it would be represented by units cubed per second. So that's the way we write it. The way we'd say it is the balloon's volume is increasing at a rate of 1,728 pi units cubed per second with respect to time when its radius is 12 units. Okay, so let me just go over a summary of like the general rules of what you have to do. Alright, so let's go over some general steps when tackling any problem. Steps. Okay, step 1. Write down what you already know. So that means, like, if you have a quantity with respect to time, you should always write it in a differential form. So for example, d something over dt. Remember, it's probably over dt because it's probably going to be like a rate they've given you. That's why it's called related rates, because you're relating one rate to the rate at which another is increasing and how it influences it. Okay, I'm going to write x because we don't actually know which quantity we're referring to in the general context over dt. Step 2, construct a general equation. So what I mean by that is, usually we'll make like a multiplication kind of equation where the quantity you want to find, which is like dA over dt, is equal to the quantity that you know, which could be dx over dt in this case, times an unknown quantity like that you have to find based on this equation. Based on this equation, if we did dA over dt divided by dx over dt, we would need to find dA over dx. So construct an equation. So you now know what you need to find, which is dA over dx. Let me just erase that so it's easier to see. Step 3, construct an equation for the rate you need to find. So in the other example where you have dA over dt equals dx over dt times dA over dx, you need to construct an equation that relates dA over dx. So that means you'd probably have like a is equal to something 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 x, like 4x squared. So like you have to write that kind of equation. In the case that we did, we were looking at the volume relating to the radius. So that would be v equals 4 over 3 pi r cubed. The next step, I'm not going to erase that just yet. Differentiate the equation. So if you have a equals 4x squared, differentiate so you can get dA over dx, and therefore easily just substitute in here. So dA over dx would be equal to 8x in this case. Then substitute the value given. So in the previous example, we had the radius is increasing, the radius at 12 cm precisely, like we were looking for the rate at that. In this case, you just substitute that in here. So if you're substituting the radius as 12, it would become 96, this value, the dA over dx value. Then put all the values in the equation. And find the unknown value, unknown rate. So basically, after you find dA over dx is equal to, well, 96 if it was x equals 12, substitute back in there. This value you already know they've given to you, so substitute that in, then do the multiplication and you can find this value promptly. Finally, you can, step 7, write the correct units. So it's always going to be per second. But like in the last problem, you could have volume, you could have surface area, you could just have, like, I don't know, height. Whatever the case is, you need to identify whether it's a cubic, a square, or a normal just like, unit. So in our case, it was a cubic unit, so we'd have to make it units cubed. And also, if they give you specific lengths like centimeters, meters, etc., you also have to put those in there in replacement with units. In the example we had, it mentioned units because it just wanted to generalize it, so you have to use units and keep it consistent in that case. Okay, well, I think that's it for this video. In the next video, I'll introduce some related rates practice problems, so I won't add any practice problems in the description of this video, but thanks so much for watching, and see you in the next one.